Hey guys, welcome back. So today we'll be going over scientific notation. And remember that scientific notation is used to express very large numbers or very small numbers. So let's look at this example here, 8.74 times 10 to the 8th power. This is written in scientific notation. So scientific notation is written as the product of a factor and then you have your power of 10. Notice here though, for your 8.74, notice that your first factor is going to always be a number that is greater than or equal to 1, but less than 10. And then your second factor here, 10 to the 8th power, this is just a power of 10. So let's look at this, 2.4 times 10 to the 6th power. This is also written in scientific notation. So you have your first factor here and your second factor. And remember the 2.4 is going to be greater than or equal to 1, but less than 10. And then you have your power of 10 here, which is 10 to the 6th power. Since this is my scientific notation here, how do I write this in standard form? So I'm going to do 2.4 and I'm going to move my decimal 6 places to the right because I have a positive exponent here. So this is going to be 1, 2, 3, 4, 5, 6. My decimal is going to stop right here. And now I'm just going to fill in the gaps here with zeros. So there's a 0 here, a 0 here, 0, 0, and 0. So if I'm converting from scientific to standard, your answer here is going to be 2.4 million, or you may read it as 2,400,000. Now let's say we have the same expression, but this time my exponent was raised to the -6th power. Remember in the other example here, we have a positive 6, but now we have a -6. So I'm going to do the same thing, except I'm going to move my decimal 6 places to the left this time. So we have 2.4, and I'm going 6 places to the left. So this is going to be 1, 2, 3, 4, 5, 6, and it puts us right here. My decimal is going to be right there. And I'm going to go ahead and just fill in the gaps here with zeros. So 0 here, 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 and here. So as a decimal in standard form, you're going to get 0.00000024. And remember, this is going to be your scientific notation here, and then these answers here are going to be your standard forms. Let's look at 5.34 times 10 to the 4th power. How do I convert this into standard form? Well, we're going to do 5.34, and because my exponent here is a positive number, that means I'm going to move my decimal 4 places to the right. So we're going to do 1, 2, 3, 4. My decimal is going to fall right here. And I'm just going to fill in the gaps here with zeros. So we have a 0 here, and we also have a 0 here. So in standard form, your final answer is going to be 53,400. So now let's try 3.27 times 10 to the -3rd power. So notice here my example, I have a negative exponent, my -3 here. So that means I need to move my decimal 3 places to the left. So we have 3.27, and I'm going to move 3 places to the left. So 1, 2, 3, it puts us right here. So now I'm going to fill in my gaps with zeros. So we have a 0 here, and we also have another 0 here. So your answer, your standard form, is going to be 0.00327. So for this same example, 3.27 times 10 to the -3rd. So remember in laws of exponent, if you have a base number raised to a negative exponent, to make your exponent positive, this is going to be 1 over 10 to the 3rd power. So essentially, this is what we are doing here. You are able to do this way, or if you do the extra step, you're going to get 3.27 times 1 over 10 to the third power. And this is going to be 3.27 times 1 over 1,000. Because 10 cubed here, this is going to be 10 times 10 times 10, which is going to give you the 1,000 in your denominator here. And then when you multiply it out, you're going to get 0.00327. So let's look at this example here, 7.42 times 10 to the fifth power. So I do have my 5 here, a positive exponent. So I know I need to move my decimal 5 places to the right. 1, 2, 3, 4, 5. It puts us right here. So now I'm going to fill in my gaps here with zeros. This is a 0 here. This is a 0, and this is a 0. So your answer here is going to be 742,000. So let's see if we did the negative. And this time, same example, but this time we have a negative exponent. So I'm going to move my decimal 5 places to the left. So we have 1, 2, 3, 4, 5. It puts us right here. So I'm going to fill in the gaps here with zeros. So you're going to get 0.0000742. Let's look at this example, 6.1 times 10 to the negative second power. I do have a negative exponent here, so I am going to move my decimal 2 places to the left. So this is going to be 1, 2. My decimal is going to be right here. And I'm going to fill in my gaps here with zeros. So I'm going to have a 0 here. So your answer is going to be 0.061 in standard form. So now let's look at this same example, but I'm going to change my exponent to a positive 2 this time. Since I have a positive 2, which is right here, I'm going to move my decimal 2 places to the right. So this is going to be 1, 2. It puts us right here. And now I'm going to fill in my gaps with zeros. So your answer here is going to be 610. Let's try 3.714 times 10 to the second power. Since my exponent here is positive, I'm going to move my decimal 2 places to the right. This is going to be 1, 2, and my decimal is going to fall right in between the 1 and the 4. So your standard form is going to be 371.4. So now let's try 3.714 times 10 to the negative second power this time. My exponent here is negative, so I'm going to move my decimal 2 places to the left. So we have 1, 2. Our new decimal is right there. I'm going to go ahead and fill in the space here with a 0. So your standard form is going to be 0.03714. 5.47 times 10 to the sixth power. This is my scientific notation. And to turn it into standard form, because I do have a positive number here, a positive exponent, so I'm going to move my decimal 6 places to the right. So we're going to do 1, 2, 3, 4, 5, 6. It places us right here. And now I'm going to fill in my spaces now with zeros. Your answer here is going to be 5,470,000. So let's try 5.47 times 10 to the negative 6 this time. So my exponent here is negative. I'm going to move 6 places to the left. So we're going to do 1, 2, 3, 4, 5, 6. It puts us right here. And now I'm going to just fill in the spaces with zeros. So 0 here, 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 and stops right here. So your answer here is going to be 0.0000547. So let's say you had this number here, this very large number here, and this is your standard form. How would I write this in scientific notation? Well, first we're going to do the same steps we've been doing. So this is going to be 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, and I can't stop here because this is 85. It is greater than 1, but it is also larger than 10. I need a number that is greater than or equal to 1, but less than 10. So instead of stopping here, I will be moving on one more and stopping right here in between the 8 and the 5. So this is going to be 8.5 times 10 to the 11th power. So let's look at this number here, another large number. So how do I write this in scientific notation? Well, I'm going to go ahead and start from here and count all the way down until I get a number that is greater than or equal to 1, but less than 10. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It puts us right here between the 3 and the 8. So my scientific notation is going to be 3.8211 times 10 to the 10th power. And let's look at the same example. And then some people may be wondering, well, how do you know your exponent is going to be a positive exponent? And the only way I know that is because this number, this large number here, is greater than 1. If your number is less than 1, then you know that your exponent is going to be negative, like this example here. This number here is less than 1. So since this number here is less than 1, I know my exponent is going to be a negative exponent. Now, how do I turn this number into scientific notation? I'm going to do the same thing. I'm going to do 1, 2, 3, 4, and it puts us right here between the 3 and the 1. And remember, you cannot go down here to the 1 and the 6 because I need a number that is greater than or equal to 1, but less than 10. So if I go here between the 31.6, that's going to defeat the purpose of setting it up into scientific notation. So in scientific notation, you're going to get 3.16 times 10 to the negative 4th power. So let's look at this example, 0.114. This is my standard form, and how do I write that in scientific notation? Well, I'm going to do the same thing. I'm going to move my decimal this time just 1 decimal place over, so it's going to fall right here between the 2 ones because I need a number that is greater than or equal to 1, but less than 10, and this is going to give it to us right here. So your answer here is going to be 1.14 times 10 to the negative 1 power. And remember, how do I know my exponent here is negative? Because this standard form here is less than 1. If it's less than 1, then you know your exponent is going to be a negative exponent. And if it's greater than 1, then you know your exponent is going to be a positive exponent. And let's try 0.00876. This is my standard form. How do I write this in scientific notation? Well, I'm going to go to my right. I'm going to do 1, 2, 3, and it puts us right here between the 8 and the 7. So in scientific notation, this is going to be 8.76 times 10 to the negative 3rd power. All right, so that is all for today, and I will see you guys in the next video. Bye, guys.